Hello, everyone. I am so sorry I cannot be there today, but we have a great day of lessons, and I'm going to try to remember how to use some of these tools on Zoom. So let me go ahead and share the notes for the window. Right. Okay, let's do that. Okay, so welcome. We're going to be taking some notes on trig derivatives. We have had a bit of exposure to this before, but we're going to kind of get a formal exposure today in these video notes. Please take your notes on the note catcher today. You will show me them to receive your stamp credit for this week. Trig derivatives, yay. Okay, guys, so some prior knowledge that you should know, and I also put it on your nose catcher is all of this. So we should know the six trig ratios: sine, cosine, tangent, secant, cosecant, cotangent. And here are their definitions using a triangle. We have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then we have the reciprocal identities. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tan. So just important things to know. Make sure this, is accessible to you. There are other important information that you should know. You want to go ahead and write these down. One very huge one is this important trig identity that we talked about in pre-calculus. And this trig identity basically comes from the unit circle. If you were to draw a right triangle in the unit circle, and let me go ahead and try to test this. Yeah, if you were to draw a right triangle in the unit circle, and you use Pythagorean theorem, you would have let's call this A, let's call this B, and then we call this C. So A squared plus B squared equals C squared, right? Pythagorean theorem on the unit circle. And on our unit circle, though, my B was cosine of the angle theta, and my A was sine of the angle theta. And remember, theta, the symbol right here, just represents an angle measure. It could be in radians or degrees. So basically, plugging into the formula, A squared is sine squared, B squared is cosine squared, and then RC squared, because it's on a unit circle, C is always 1. So 1 squared is equal to 1. So this is where this very important identity comes from. And this is the first of the Pythagorean identities. Now, if you were to subtract sine squared from both sides of this equation, you get kind of like a new identity right here. Sine squared equals 1 minus cosine squared. Now, we were also able to come up with these two additional identities. 1 plus tangent squared equals secant squared, and also 1 plus cotangent squared equals cosecant squared. And those came about, for example, the second one, we're able to come up with this identity by dividing everything by cosine squared in this first identity to get the second one. And you get this third identity by dividing everything by sine squared. That's how we get this third identity. But again, we also have the secondary identities. So for the second identity, if I rearrange terms or basically get tan squared by itself, I get secant squared minus 1. Likewise, in this third identity, I kind of have this mini new identity. If I subtract 1 from both sides, I get this new identity. So those are important things to know. So just please write them down. You're not expected to derive them. I was just giving a brief background on how we got them last year and how we've worked with them. Right now, you just want to write them down because we'll be using them in some of the proofs. Okay, okay. And again, I'm practicing how to use the annotation tool. It's been a bit, so let me clear my screen. And please, oh, there we go. Please pause the video, obviously, if it's going too fast, and take your time to write these down. Okay, let's move on. Um, hmm. Okay, great. So, before, I don't know, this was 2 weeks ago, we did a Desmos activity where we've learned that the derivative of sine is cosine. And then the derivative of cosine is actually negative sine. And we were able to figure these out. on Desmos by drawing tangent lines. For example, this is my sine function. I drew tangent lines, right, on the sine function. And if you were to graph the slopes of those tangent lines, you end up getting a cosine function. That's pretty cool. And then here in red is my cosine function. Again, if I draw tangent lines and I graph the slopes of those tangent lines, you're going to get a sine wave, but it's going to be the negative sine wave. So it's basically sine function, but negative. So it's kind of not reciprocated, sorry, reflected across the x-axis. So that's why you get this negative sine function. So that was just kind of some prior knowledge to make sure we get down. Make sure you write down the derivative of sine and the derivative of cosine, please. Okay, great. So basically this task is to this task, the purpose of this is to make sure you know where these other derivatives come from. So for example, determining that the derivative of tangent x and what that is equal to. If you look at the resource sheet that you got today, you have the derivatives of different types of functions, including tangent x. I believe if you look on there, you should see that the derivative of tangent x is secant squared x. So we're going to show how we get that though. So again, for our final as well, guys, you will be expected to show how we get the derivative of either tangent x or the other functions, cotangent of x or even cosecant and so forth. So keep that in mind. Okay, so let's do this. So I'm gonna get my annotation tool. Let's try this out, guys. This is way faster on the board, I'll tell you. So, first off, apologies for my terrible handwriting as usual. Um, so I'm just gonna write down this function. So my goal is to get the derivative of tangent of x. But before that, I'm going to rewrite the tangent function as its definition, which is sine over cosine. And for that reason, so great. So I rewrote the tangent as its definition, which is defined as sine over cosine. And then what I'm going to do is I'm going to use the quotient rule to, kind of determine these derivatives. Okay, so the quotient rule says you take the derivative of the top function. So we know the derivative of the top function is cosine of x. Again, you can look at your resource or look at these notes. And then the quotient rule says to keep the second function or the bottom function the same. So that's multiplied another cosine x minus keep your top function the same. And then you take the derivative of your bottom function, which is the derivative of cosine is negative sine. So I'm just going to add a parentheses here because this is a negative. And you'll see some stuff will happen with this in a second. And then quotient rule, we cannot forget it's all over the bottom function squared. And the proper way, you can use parentheses squared, or sometimes you put the squared like this, traditionally is how we write it. Okay, so this is what we have. Again, apologies for the messy handwriting, but I'm going to go ahead and try to simplify this. So cosine times cosine is equal to cosine squared. Guys, how did I do this in the past? How did I do Zoom teaching? Anyways, negative times negative, that's a positive. And then we have two sines, so that's going to be sine squared. So basically, as I'm writing this out, I hope this is like looking like one of the identities that we wrote down in the list earlier. Because it is to me, guys. So, and the numerator position, what you have is basically, I guess I'll change colors, is basically the main cosine, the main Pythagorean identity, which is the sine squared plus cosine squared is equal to 1. Again, it doesn't matter if cosine is first or sine is first because, you know, uh, addition has this commutative property where it doesn't matter whether you write it forward or backward because it's addition. It means the same thing. So anyways, cosine squared plus sine squared, guys, that's equal to 1. all over. So this is equal to 1 from our identities all over. And then the cosine square just comes with us. Yay. Okay. Very last thing is what is 1 divided by cosine? We know that 1 over cosine is defined as secant of x. So this is going to become not just secant of x, but because this cosine is squared, it's going to become secant of x squared. And we have now thus proven that the derivative of my sine function, sorry, let's be formal. The derivative, there we go, of my, sorry, tangent function. We have now taken the derivative, so that's why I kind of put my proper notation right there. The derivative of my tangent function, we have proven to be secant squared x using quotient rule. And actually, you're able to use quotient rule for the rest of the trig functions to prove their derivatives. And again, these knowing that the derivative of sine and cosine that came from the prior graph activity, so we're kind of building upon that knowledge and incorporating here. So again, please pause the video and get this down if you need to. And other than that, I'm going to clear the screen. So pause the video if you need to do that. Cool. So let's go ahead and move on. So my intention was that you guys would do these in teams, right? Like you would figure out what the derivative of cotangent is using quotient rule, and you determine the derivative of secant x using quotient rule. But what I'd like you to do instead, because I'm not there and we don't have our new teams, is basically to pause the video and give it a shot, and then start the video again, and I'll give the answer. I hope that sounds like a good middle ground for what to do instead. So yeah, I'm gonna start it. So um, for all of these, we're gonna be using quotient rule to prove them. So the derivative of cotangent x, we're gonna figure out what that is, but you do have this on your resource sheet. So you should know what it is now. And by the way, if you don't have that derivative resource sheet, please ask to get it. But this is again, this is about proving how to get there, right? Again, we want to know how to prove how to get the derivative of cotangent x. We don't want to just know what it is. We are expected to know how to prove them using quotient rule. So here it is. So the first step to proving this using quotient rule is quotient rule requires us to have a ratio, or basically a division of functions. So let's rewrite cotangent as what it represents. Cotangent by definition is cosine over sine. So again, cotangent is the reciprocal of tangent, and thus it is cosine over sine. Yeah. So again, we're going to use quotient rule. By the way, alternatively, if you were interested, you could have also just used the proof for tangent and just reciprocate it to get your cotangent. But let's try it this way. Quotient rule. So basically, take the derivative of the top function. We know that's negative sine. Keep the bottom function the same, which is just sine. These are multiplied. Subtract. Keep the top function the same. And then we're going to take the derivative of the bottom function, and the derivative of sine is plain old cosine. And then all over the bottom squared. So it's all over sine squared of x. It's a big X of x. There we go. Okay, cool. So again, this top kind of looks very familiar a bit. So again, we have two sines. So that's going to become negative sine squared x. Minus, and then we have cosine squared x. All over sine squared x. Okay, so now we're gonna pause here. Now this top kind of looks like the first Pythagorean identity, right? Where sine squared plus cosine squared equals 1. However, the issue is we kind of have negatives going on here, so we can't really yet use the identity. But here's what we want to do though, guys, is because there's a negative here and a negative here, we literally, guys, can just factor out a -1. And then we'll be able to actually get our identity. So take a look here. So that if I factor out a -1, we're going to get sine squared plus cosine squared all over sine squared. E, there we go, of x. Okay, so that's, by the way, that one looks so bad. Let's see, let's try to fix that. Sine squared of x. I don't know if this looks even better, but anyways, great. So we're here. We've now created an opportunity to use our Pythagorean identity. So sine squared plus cosine squared, that is equal to 1. So -1 times +1 is simply -1. So let's go to this new side, and we basically just have -1 on the top all over sine squared x. And we're like almost there, guys. So now the last thing is remembering that 1 over sine of x is equal to cosecant by definition. And we have, so 1 over sine is equal to cosecant, but because we have this negative here, that's going to become negative cosecant squared of x. And again, it's squared because the sine was squared. And boom, we have now shown that the derivative of cotangent, guys, is negative cosecant squared of x using the quotient rule for derivatives. Cool. So hopefully, yeah. And again, feel free to pause this video if you want to give it a shot for secant of x. Oh yes, one last detail, guys. Let's be proper in format. I have found the derivative of the j function, so I added the little derivative symbol there. Always just go back and make sure that you're good with your notation. So yeah. Okay, guys, let's do the secant function. So, again, in order for me to use quotient rule, I'm going to rewrite secant as what it represents, to make it a fraction, if you will, or to make it a ratio of fractions. So secant by definition is 1 over cosine of x. That's just by definition. And your first set of notes that we have, and the first copy of it. And then honestly, guys, quotient rule when you have a constant is very beautiful because as we all know, the derivative of a constant is 0, and that's gonna make our work really nice. So let's do this, guys. Okay, so we're gonna take the derivative of the top function, that's 0. Yay. And then multiply by your bottom function. Subtract, keep your top function the same. And then we're going to take the derivative of the bottom function, which we know the derivative of cosine is negative sine. Those are just the parts to know. You want to just know the derivative of sine and cosine for these proofs. All over the bottom squared. The bottom is just cosine squared of x. So 0 times anything is legit 0. And then we have negative times negative, that's positive. So then we have sine of x all over cosine squared x. So to be frank, you guys have your resource. Uh, I'm gonna try to write this as the resource has it. So this is, by the way, this is as simplified as I can get. So what I'm gonna do is I remember the resource does not have this as a derivative of secant x. I know there's a different way they write it, so I'm going to write it the way it's on your resource. So this is indeed the derivative. Now let's use the formal notation. There's now the derivative of secant of x, but we got to simplify. So what does it look like in this case to simplify? The way it's on your resource sheet, it's like this. So what we're going to do is we're going to rewrite this as sine x um, all over one of the cosine x's, just one of them. I'm just kind of separating this fraction or splitting it. So I'm just rewriting the fraction like this, okay? I hope you guys agree that that's true, that I can do that. So sine x over cosine squared x is the same thing as saying sine over cosine x times 1 over cosine x, because if we were to multiply these across, we literally get the same thing. So first off, you got to agree that that's true. Next is sine over cosine. We know that is tangent by definition. And then 1 over cosine, by definition, we know is secant. So this is tan of x times secant of x. And I believe that's how your resource has it written down. This is a secant. Again, this is on your resource. You could verify that. And there we go. So the derivative of secant of x, guys, is tangent times secant of x. Yay. We are basically there. So y'all, oops, I gotta clear my screen. So again, please pause the screen if you need to get any of this prior stuff down. But for our final, right? For our final, you should know to show using algebra in the quotient rule, or prove using algebra and the quotient rule to determine the derivatives and show the derivatives are for tangent, cotangent, secant, and cosecant. So I think I did like these ones. I didn't do cosecant yet, but you know, it follows the same thing, the same idea. Cool. So again, if there's any questions, you want to just make sure you jot them down for me so that we can come together and talk about it. Let me stop my share. And then, sorry, I want to kind of just show you the um, worksheet that you will be doing next. And again, you want to show me this worksheet. So it's going to be right here. I think it's is actually going to be relabeled as task 16, guys, when you get this from the sub. So basically here, you have a worksheet that you're going to be doing. You're going to be finding the derivative of all of these, but guys, you're going to just be using that resource sheet that you're going to receive. So the resource sheet is right here. So right there, you have all these definitions. So again, on this task that you're doing, you're literally just going to be applying product rule, but using this resource for the definitions of the derivatives. And some of these are just given to you. For example, we didn't talk about the derivative of natural log of x, but you're going to be expected to use it. The same for the log function. So as long as you have the definitions, you'll be able to use this resource. And guess what? This resource, right? The calculus derivative resource sheet, you'll be allowed to use this for the final, by the way. On this task right here, and I just don't know where's my Zoom tools. Oh, there we go. I'm just gonna do a quick, no, sorry, I have to do this big. Oh, how weird. Sorry, guys, you weren't seeing what I'm seeing. Anyway, so let me just show you again. So basically, for this task, you're expected to use the calculus derivative resource sheet, right? You're given the definition of many of these. And again, these ones you guys should know how to prove for the final using quotient rule. And you can ask me about any of these. I've showed you already 3 samples. And now some of them, the exponential and log ones, I am just giving to you. We didn't really talk about the proofs for those, but yes, I expect you to just use them because they're given to you already. So for example, the task that you're going to receive today looks like this. It says find the derivative of the following. You're going to notice that in the first bit, it's mostly going to be um, product rule. See, because sine x times cosine x, that means we're multiplying, so we'll be using product rule. Um, so let me just, for example, and by the way, all of these, I call them f of x. You can call it whatever you want if you want to switch what we call it, but let me just give an example. So the derivative of sine x according to the resource sheet is cosine of x. Product rule says I keep the second function the same. And then product rule says I have to keep the first function the same, and then take the derivative of the second. And by the way, some of these are not going to simplify nicely. You're just going to leave it as a long train of stuff, and that's okay. Now, some of you might remember nice trig identities, and you can use those as well. But for the most part, I just want you guys to practice using the derivative resource sheet to figure out these identities. So this is what I get once I simplify this. So if you can simplify like the way I'm doing, guys, then do that, please. This will be the answer. So all I did is I used this knowledge that the derivative of sine is cosine, the derivative of cosine is negative sine. I'll be using this derivative resource sheet to figure out the rest of these using the product rule. So again, you have all these, you're going to use that, and you're going to give this a shot. And I want to see this because I want to see how far you get through this on your own. So notice for number two, you're going to have this log function and also this natural log function, right? You're going to do the product rule and you're going to just go and check the derivative resource sheet, right? So you have the derivative of the log function right here, right here. And then you have the derivative of the natural log function right here. You're just literally going to go ahead and try your best to copy that down. You could check in with the people around you. Um, or you could put a star by them and ask me some questions about them. So that's the front of this. The back of this sheet. Oh, I think it's all product rule. I'm kind of like surprised. I kind of wish I put some quotient rule on these, but I didn't. So great. You guys are going to get a practice with product rule and using this derivative resource sheet. Please talk with each other. Please put down stars and questions you're stuck on. And then I'll make sure to kind of put these on our do now so we could talk about it. Okay, guys, good luck. I'm waiting for you guys. Bye.